So last time we ended with P Wilcox, Q Wilcox in R, but I saved something for this time. So a variation of Wilcoxon-Brunson, or the W statistic, is the Mann-Whitney U-statistic. What is so different, and why should we bother about this before we get to an example? P Wilcox, Q Wilcox that I showed in R uses Mann-Whitney and not W. So nothing too complicated though, they are very related. So if we have a bunch of observations, xi, sample 1, I believe it, we called it 1 through m, and yi sample 2, or yj, how much that? One to n, we defined the Wilcoxon-Brunson statistic as some we'll use j. J equals 1 through n. I believe that is the notation that I used. So all we're doing is adding the ranks in the combined sample corresponding to y. Of course, I mentioned last time, it really doesn't matter whether you use x or y, symmetry and all that. So that is the Wilcoxon statistic, but R uses U, something called the Mann-Whitney U-statistic. What is the key difference? The Mann-Whitney U-statistic is going to use our same usual indicator function. And it will define 1 if xi is less than yj, 0 otherwise. This is what we call x before y. It does. So if the value of xi is less than yj, then we use x before y. That is the definition. So what is u then? Sum I equals 1 to m, j equals 1 to n. Sum all the indicators that we have. In other words, we are simply adding xi less than yj cases. That statistic is what we call the Mann-Whitney U-statistic. Pretty much in a way we are trying to take out observations that are less than yj. Even though this seems sort of easy, some might prefer using the W statistic instead. So there is a relationship between U and W. W is simply U plus n times n plus 1 over 2. That comes from the yi values, sum of the rounds corresponding to y. So even if we find U, we can find W using U. Yes.
What does the second line of the piecewise function mean?
That one?
Yeah.
0 otherwise.
Okay.
OW means otherwise. I assumed you guys knew my bad. O.W otherwise. So if you find U, you can find W. Likewise, if you find W, you can find U. W minus n times n plus 1 over 2 would simply be equal to U. Good. Same logic can be applied to the critical values. That is W. So W sub alpha will be in the support of W. So the critical value, if you want to find it on the left-hand side, right-hand side, all we have to do is to find U sub alpha and add n times n plus 1 over 2. Good so far. Now here is another catch. Blame the person who wrote the program in R. When the person wrote it, person didn't do X before Y, person did Y before X. So if you want to use R, Y before X is employed. So if I want to find the critical value for W, and if I want to use R, I've got to do some changes here to get to Y before X. Your book calls it U prime. U prime is computed for Y before X. Simply whatever U value you have to subtract by M. Good. So if I have to use U sub alpha over there, when I use P Wilcox, Q Wilcox, it is going to give me U sub alpha minus Mn in R. So we've got to rearrange this. Write it this way. So that would be the value provided by R. We have to take that value, add m times n, put it back in there to find the critical value for W. Does that make sense? In a similar manner, if we find the W statistic, we have to convert it to U. U needs to be converted to U prime, and then put in R to find the P value. Does that make sense? So this relationship matters. One may say, well, why should we take this approach instead of assigning ranks? Well, when you have large numbers and you try to put them in order and try to rank them, sum them, all sorts of stuff, computation might become heavy. But if I rewrote it this way, all I'm doing is adding a bunch of ones and zeros, correct? So computationally, this is efficient. Does that make sense? But they are related. You can go from one to the other easily. So the key here is once we find W, and if we're going to use R, we've got to convert W to U, U to U prime, and use U prime to find the critical value, to find the P value, and so forth. Good. So chain of events, fortunate. Of course, you may ask, well, what should I do if I'm performing a large sample approximation? Well, you can either use W, or you can use U, or you can use U prime, but U prime and U will have the same expectation, same variance. W from last time, what is the expectation of W? Yes. If I want to find the expectation of U, I'm not sure if you guys know this, properties of expectation. If you take problem stance, you know. If not, no big deal. If I have a random variable x multiplied by some numerical constant a added to b, this is the same as saying expectation of x multiplied by a plus b. Always. Take a guess as to what var means. Variance. You should know this, Claire. What will that equal to? All right, so should Paul, what will this equal to? I put Claire on the spot, she put you on the spot. Huh? You guys are breaking my heart on Monday. How can I live through this week?
You can live through it by not having it yet. But we can all.
Yeah, that's a covariance.
Right, so a squared variance of x, b is a constant. So anytime, a constant does not vary. So variance of b, which is this.
It's because we used the ABC one. And
The
then we
covariance.
had to like do it all. Yeah, okay. I think I have my cheat sheets.
I was remembered that covariance.
Yeah, so what we did in time series, we did covariance ax plus b comma cx plus b.
Yeah.
That's why.
Very different.
At least you remember that part. So we know W is U plus N times N plus 1 over 2. U W minus N times N plus 1 over 2. Think of expectation as applying the derivative on both sides or square roots on both sides to keep things easier. So expectation of U is equal to the expectation of W minus N times N plus 1 over 2. Again, statistics is not about just memorizing formulas. You've got to know why it works. Going back to that, B is that constant, A is 1. So I can write this as E of W minus N times N plus 1 over 2. Yes, we know what that is. N times M plus N plus 1 over 2 minus N times N plus 1 over 2. If I distribute the N, I will have N times N plus N times N plus 1 divided by 2 minus N times N plus 1 divided by 2. But wait so far. So common denominator. So N over 2 plus N times N plus 1 over 2 minus N times N plus 1 over 2. Yes, I just split them. Now that part and that part will get cancelled. So the expectation of U is simply N times N divided by 2. If you choose to use U instead of W, simply M times N over 2. What about the variance of U? Variance of U, just like the expectation, to keep things easier, think of it this way: you apply the variance on both sides. So variance of U would be variance of W minus N times N plus 1 over 2. Good. I asked you this, what would that equal to? So this would simply equal to the variance of W, because according to my remark, if I have a constant added to a term, it would simply end up being the variance of W, which we know from last time, N times N plus N plus 1 over 12. Good. Now, erase. The statement that I'm going to make is U and U prime will have the same expectation and variance. It's not going to change. They are symmetric for one. What is an easier way to show that? Well, if you start with U prime, I know U prime is U minus Mn. Or is it U plus Mn? What would it be? It's U. No.
U prime is U minus.
U minus Mn. So expectation of U prime would be expectation of U minus expectation of Mn. And what is expectation of U, which we just found? Variance of U prime would simply be equal to variance of U because I'm subtracting a constant. So expectation of U prime would simply be equal to the expectation of U because of symmetry. Variance of U prime would be equal to the variance of U. So again, you can't have a negative expectation when your support is from 0, 1, 2, all the way up to Mn. One may ask, well, why should it be all the way up to Mn? Because you have n observations for x, n observations for y. When you find phi of xi, yi, it's a cross product of m times n possibilities. So the maximum value has to be m times n. Good. So the key takeaways, whether you use W, U, U prime, doesn't matter. However, if we are going to rely on R, we have to start with W, convert it to U, then to U prime, then we could use R. Again, don't blame me, blame the person who wrote the code.